The last case study we are going to see is called BAMBI, Ballon against postpartum maternal bleeding. It is presented by Francesco de Gaetano from Polytechnic of Milan. Yeah. Thank you to be here.
Thank you. Thank you very much. I'm Francesco de Gaetano. I'm a biomedical engineer and I'm a senior researcher at the Politecnico di Milan, in particular the Department of Chemistry, Material and Chemical Engineering. And I'm very delighted to be here to present you the last result about our case study, the BAMBI, that aims to fight maternal bleeding. So in the last presentation, we saw what can happen during the pregnancy. And now we will see what can happen at the late stage of the pregnancy, at the childbirth. So, okay. So we are focusing on the uterus, what happened inside the uterus during the childbirth. So just a brief introduction about the uterus. The uterus is the pear-shaped hollow organs that can stretch a lot. We have just imagined that for not pregnant women, the dimensions are around 200 milliliter, the volume of the uterus, but can reach up to 4.5 liter at the 40th week of pregnancy. The external layer of the uterus is a very thick tissue that can contract a lot, and these contractions are useful, are necessary for the childbirth, but are also necessary to stop the hemorrhage that can occur during the childbirth. During this process are also involved the cervix, that is a round-shaped tissue that can enlarge until 10 centimeters, and of course the narrow channel, the vagina, where the baby is delivered. So, what is the postpartum hemorrhages? The postpartum hemorrhage is the bleeding, the loss of at least 500 milliliter of blood in the 24 hours after the childbirth. But pay attention that these 500 milliliter can be lost in more or less 3 minutes, because during the hemorrhages, the flow rate is around 200-300 milliliter per minute. So you have to manage this disease in a very short time. And this is the leading cause of maternal death worldwide. If we go deeply in the number, we can say every year we have 14 million of postpartum hemorrhages, and 170,000 of these are related to death. The most shocking number is the one where these deaths are located, because the 99% of death happened in the low-middle income country. The picture is very clear. We have most of the cases in the sub-Saharan country and a lot of cases in the southeast of Asia. And the WHO have very clear in mind this problem. As Domenico Vito well explained you yesterday, there are several goals that the WHO have in mind to solve. And relate to the goal number 3, there is a subtask related to the PPH, because it's the leading cause of a huge gap in the life expectancy of life between women in low-income countries and developed countries. 31 years is a huge gap, and mostly recognized to only one disease, the postpartum hemorrhage. All other diseases that happen, the COVID didn't help to solve this problem. You have to have in mind how the childbirth happen in this country. There are not so much hospital, or if there are these hospitals are far from several rural zones. There are a lot of camp hospitals that are not easily accessible for all the people, and the COVID made this access lower. So, as reported, okay. As reported by a report made by the Bill and Melinda Gates Foundation, in 2019, the number of postpartum hemorrhages, or the number of the deaths related to the postpartum hemorrhage in 2019 was 144 every 100,000 live births. And the WHO pushed this threshold to 17 for 2030. But unfortunately, due to the COVID, according to this report, it will be quite impossible to reach this number. And we are more close to the worst scenario, where in 2030, more or less, the number remains the same. And this is also due on how the money will be spent in the research and in the activity that will be focused on other pandemic or other situations instead of postpartum hemorrhages. So, how we can treat nowadays the postpartum hemorrhages? There are mainly two ways. The first is a pharmacotherapeutic management. So when we talk about postpartum hemorrhages, we have the uterus that can contract. So we talk about atony of the uterus. So using some drug like oxytocin, we can improve the contraction of the uterus and also stop the bleeding. Unfortunately, the drugs are not always available in the low and middle income countries, so we have to pass on other device, a mechanical device, the so-called uterine balloon tamponade. And here I have one of the most used uterine balloon tamponade, that is the so-called Bakri balloon. They are very easy to use. You have just to insert through the vagina and the cervix the balloon inside, the catheter inside the uterus. Then you have to inflate with saline solution, 500 ml of saline solution, until the balloon goes all around the lower part of the uterus, stopping the bleeding. Then you have to put this device for 48 hours. After that, you can remove the water and then retract the device. So the device is quite simple to use and work very well. Where is the problem? The problem is the cost. The cost is extremely high. You have to think about that the Cook Medical, that is the company that produced the Bakri balloon, have a marketplace, it's a huge marketplace for this device, and the mean cost of this device can range from $250 till $350. That is quite impossible. Is a cost quite impossible for low and income countries. But not only for that country. Also in Italy, we don't have this device because it's too costly, it's too expensive. So in Italy, we can manage the PPH only with the oxytocin. If we don't have this drug, we can manage another way. So there are some alternatives, lower cost alternatives. One is use other catheter that are not intended for PPH as the Foley catheter, so have a different shape, are not perfect, so you have to use more than one, but is very tricky to use 2 or 3 Foley catheter inside the uterus and be sure that you can stop the bleeding. Or there is some emergency method, the so-called condom balloon tamponade. They are very quite simple but unsafe because you have to insert a condom over a standard catheter as a Foley catheter. Then you have to tie using an elastic band. After that, you can fill with water and then use surgical instrument like a clamp to insert this balloon inside the uterus. The problem is that after 2 or 3 hours, they start to leak. So we need a device that have to be maintained inside the uterus for 48 hours, and after 2 or 3 hours, we have leakaging. We have another problem. Sometimes to fill the space, the doctor uses gauges. But when you use gauze and you start to have bleeding, you doesn't have immediately the feeling of how is the bleeding. So when you start to see bleeding through the gauge, it's too late because the women are already lost 400, 600 milliliters of blood. So if you saw on the corner on the left, there is, okay, on the right, there are an empty space in the device that are easy to apply, but also cheap. And this is the main goal of the BAMBI kit. Gave to all the population a kit that is easy to use, that is safe, but can also be cheap for all the countries that they want to use this device. So we saw that basically there are 2 kinds of device. The uterine balloon tamponade that work very well, and the condom balloon tamponade that are cheap but are not safe. Both of that require surgical instrumentation to be inserted inside the uterus, so they are not easily usable in this country. This is why we propose a new idea, a new device that is economically affordable with the ideal price lower than $5, easy to use because that didn't require any surgical instrumentation, and safe. Our kit is made by 4 parts, and here I can show you these 4 parts. So we have a standard rectal probe that is very useful because it's more rigid than the standard catheter that are used. So you can use without any surgical instrumentation. But the tip is very soft, so you don't risk to damage the vagina or the uterus that after this, the childbirth are very soft and delicate. Then we have a standard probe cover that you have to open and scroll all around the catheter. And after that, you have to apply on the top our connector and then rotate. Because inside there are some elastic band, we will see, that fix the condom over the probe. Then, I'm sorry, I lost some water on the table, then I promise that I will clean everything. Then you have just to connect your bag that was pre-filled with saline solution or water, sterilized water. You can just put the bag at least 1 meter over the uterus, and for gravity, the balloon starts to fill. Obviously, after that, you position the catheter inside the uterus. Here, you can check when you arrive more or less at 500 milliliters of water. After that, you can close and let the bag behind the patient. After 48 hours, you can just put the bag down, open the clamp, and automatically the balloon will be empty, and you can easily remove from the uterus. The main idea of this kit is the connector, and is also the only part that we patent. Why was so important to patent this device? We talk about open science and how to spread the innovation all around the world. It was important because we have some contact with companies that work in low and middle income countries, and they ask us to patent the device because it's more safe and is and there was more easily to spread around if you have the patent, because you don't risk to have competitor that can copy in a bad way your idea and try to make a not safe device. We go beyond this patent because we made a so-called social patent. So all the inventor here in the Polytechnic, because we are all researchers of the Polytechnic, we undertook to waive all rights of the patent, and also the Polytechnic is committed to give a free license of this patent to the company that we oblige to produce at a low price this device. So in that case, we can control in which company this patent go and how they use it, because we had a very bad experience with some company where we sell them the patent and they put on the throw because it's not convenient for the market point of view, and they decide to maintain their market as it is. So we prefer have the licensing of the patent and decide how at which company gave this patent under some condition. So I show you how to directly how to use our device. So the step that I was insert inside the simulator and then start to fill it. So how we create our device? We are in a research field. We are not already on the market, so we start with prototypes. In our lab, we have some 3D printer facilities, so we decide to 3D printer all the device that we need in this prototyping phase. So, which material? Because Formlab is a well-known printer. There are, I think, more than 20 different materials with different mechanical properties. So, we select one of the resin that have the highest mechanical characteristics in terms of elastic modulus and ultimate strength. And before to start with the prototyping, we perform some numerical simulation to understand if during the assembling of the device and during the working phase of the device, we have the maximum stress that is lower than the ultimate strength. And we have very good result because we are more or less at the half of the ultimate strength. So from the CAD, we pass to the prototypes. Now, as Professor De Maria explained yesterday, if you want to go on the market, we have to perform some tests that goes in this direction. So we start to search on MDR, which could be the test that we have to do. Nothing, because there are no standards that tell you which kind of test you have to do for this device. If you want to make a new heart valve prosthesis or a ventricular assist device, you have, I think, from 3 to 6 standards that explain you not only which kind of tests you have to do, but the setup that you have to build up if you want to use your own setup, which are the equip that you have to use for the measurement. So the sensitivity of the pressure sensor, the sensitivity of the flow rate probe. You have a lot of information. And you have also the minimum requirement. For example, for a heart valve prosthesis, you know which is the minimum effect orifice area, regurgitation, durability, and so on. For the ventricular assist device, for example, you know which are the maximum free plasma hemoglobin to understand the hemolysis of that valve. On this device, you don't have anything from the MDR point of view, neither from the FDA. We searched so in the literature because we know that the Bakri balloon was FDA approved. So we searched both in the FDA and both in the literature review, and we found some tests. But we decided to go further because we don't only try to test the performances of the valve, but in particular we test the safety of the device in terms of displacement of the condom from the catheter. We use as reference the Bakri balloon, so we made all the tests also in the same condition, also with the Bakri balloon that is the gold standard already used, and we can observe the behavior of our device. Okay. No. Okay, we perform two kinds of tests to evaluate the performances. First are open-air tests. So we start to inflate the balloon with 500 milliliters. That is more or less the standard, the volume that we need to stop the bleeding. And also in situ tests using a standard simulator that are already on the market. So we are able to measure the intraluminar pressure, so the pressure inside the balloon, and compare with the Bakri balloon. But here I have the simulator. The in situ tests are fundamental because there are already on the market some phantom like that allow you to simulate the PPH. So simulating the PPH, you can also understand how your device works. Here we have two tubes that we can connect to, let's say, blood. We can put in pressure the blood and start that the blood start to bleed from the uterus, insert our device, start to inflating, and observe in how many times it start to stop the hemorrhages. But how you can see here, we have just one dimension of the cervix, and we know that the cervix can vary from 2 to 10 centimeters. And changing the dimension of the cervix can change a lot the reply of the system, both our system, but also the Bakri balloon. So we go also beyond developing our simulator. So we made a simulator that is flexible because can be modular. So we have two parts connected. The back part is the uterus, and the front part is the cervix. So we can modulate different shape and dimension of uterus and cervix. We can mimic the bleeding, but we can also measure the pressure inside the uterus because we have two factors that help to stop the bleeding. The one is the mechanical shape of the balloon that goes on the wall and stop the bleeding. The second is the little amount of pressure that you have inside the uterus that help to stop the bleeding. So here you can see the result. The curve are well representative of also Bakri balloons, so are exactly the same because the material of the condom, of the probe cover that we use is very similar to the material of the balloon. And we observe that is the only properties that can affect the intraluminar pressure. We observe that we have a different shape in our device, and our device can change the shape, changing the positioning of our connector, considering the distal part of the catheter. So we start to analyze also how the shape and how the volume can change, and we observe only differences in the shape of the balloon, not difference in the working of the device and in the measuring of the pressure, because it's so elastic, the condom, that even if you reduce the part that can inflate, the pressure didn't change so much. And last but not least, we made also what we call safe tests, because we try to estimate the maximum force that you need to displace the condom, the probe cover, from the rectal probe. And this is fundamental at the end of the use of this condom balloon tamponade, when you have to remove your device from the uterus, because you have to be quite sure that nothing remains inside the uterus, of course. So we perform this test with a standard machine, and we observe that the maximum force that we need is 10 Newton. Is lower than the force that we acquired with the Bakri balloon. Is more or less the half. But because in the Bakri balloon, I lost the Bakri balloon, it's here. You can stretch directly the part that it was to inflate. You can stretch the tip, so the tip is more rigid than this part, so you don't have this risk, because it's made in a well good way. This is the best on the market, so of course is made well. But according to some gynecologists, we made several tests to understand which could be the maximum force, and we goes around 3 Newton. So 10 Newton is a good result. But we try to have a better performances in 2 ways. First, understand how changing the distances can change the distances of the connector in relationship to the end of the probe, can change the maximum force. But also, how many rotations we have to do in order to increase the strength of the device. And we find 3 rotations, the perfect compromise between safety that the elastic band doesn't break and the maximum force with a huge displacement. Then we were curious to understand how this device could work for people that are not trained. So we decided to take 5 researchers that work in our lab. We select 5 computational guides that are less involved in experimental tests, so we hope that have lower manuality with this device. And the results were quite impressive. Not only because our device required lower time, because 30 seconds compared to 1 minute is not, okay, it's half, but it's not a huge time also 1 minute. 1 minute is a perfect time. But the most important thing is that using the emergency device, the most of them failed because they didn't put the elastic band in the proper way. So they have bleeding, or they have a break of the elastic during the procedure. And always, as Professor De Maria told yesterday, one thing are the prototypes that you use in the lab. And other things are the real device that you have to test for MDR certification or whatever you want. And it's quite impossible to think that a 3D printer device will be on the market, because even if it's cheap, it's not the cheapest way to produce a plastic part. So we talk about a company, MTTS, that work in this field, is an expert in injection molding, and they gave us different feedback on how to improve the design in order to be sure that these 2 parts could be easily injection molding produced. I remember that using the injection molding, you can reduce a lot the cost. Using injection molding, you can pay 15 cents both the part of our device. So we decided to reprint the new shape just in order to understand if the shape can change the performances of our device. And we observed that from the working point of view, nothing changed. The intraluminar pressure and the intrauterine pressure are the same. But it's quite obvious because it's something that depends not on the device but the condom. So we observed that there are no leakage, so this is very good. And surprising, we observed that the The force that we reached before with the lowest configuration that reached more or less 10 Newton, now was more or less double, just changing the design. So this changing in just changing this design not only helped to reduce the cost, but also increase the safety of our device. So, which are the beneficiaries of this, let's say, invention? First of all the mom. Not only in this country, but all over the world, because I remind you that there are no Italian hospital with a Bakri balloon. Of course, the hospital are the second entity, can have several improvement in the management because they have an option. Even if when the drug doesn't work, they have an option to treat the PPH. But all this work is a father, let's say, that is Dr. Zanini. He came to us in 2018 with several needs. And he was very struck that the postpartum hemorrhage, that was quite simple to manage if you have the right device, is such a problem in the low and income countries. So he come in our labs, we start to have a brainstorming, and we start to perform some idea how to define this device. After that, we involved several NGO and profit organizations like QAM, Solitaire, and ANT, Amici della Neonatologia Trentina, that help us to understand in which country and how it could be possible to insert this device, and which is the best way to reduce the barrier that you have when you have to go inside a market. And then we have to thank Polytechnico because gave us several grants. There are several competitions inside the Polytechnico, both for the student but also for the researcher. Two in particular, Switch to Product and Polysocial Award, aim to give money to brilliant idea that have a social impact. We were very lucky because we won these two grants, and this is how our story started, because we won this grant and we started to patent the idea. Then we start to collaborate with this no-profit organization that gives us some hint on the direction that we have to take and on which test we have to perform. So we more or less we have done the in vitro phase. We just have the ethical approval for perform a huge number of simulation tests with a doctor or people that are not trained in this field, just to understand if compared the Bakri balloon and the emergency device, the BAMBI balloon can have some success. And then talking with some industrial partners that are interested in our work, we aim to make some tests on field in the first trimester of the next year, and then start the production of the connector that we will sell as kit with the condom, the catheter, and so on. Obviously, this is a work made by a huge team, let's say a dream team. First of all, Professor Costantino, that support us in all the activity, and Professor Graziosi from the mechanical department that help us during all the phase of the manufacturing of the prototype. And last but not least, the PhD students that are the heart of every project, so Kasra and Sara, that help us during all the phase. As Polytechnico, we are also very lucky because we have a good transfer officer, so they help a lot us during the patent procedure. So Anna Plebani follow us and call us every day for the deadline that the patent process have, so we made a good work. And of course, we have to thank also all the people that are involved, our partner and the NGO. I think that I am in time, yep. So I want just to spend few more words. I'm a researcher from 2013. I started my PhD in 2013, and I attended several congresses. In all that congress that I attended, all the congresses that I attended were full of high technology research, VAD, ventricular assist device, heart valve prosthesis, numerical simulation, very difficult numerical patient-specific numerical simulation. So very attractive from the scientific point of view research. But there are no talk about device that maybe have a low interest because are low technology compared to a VAD or a valve prosthesis, but could have a huge social impact. And last week, I was to a conference that our group attends every year, the European Society for Artificial Organs, and I present a talk on the BAMBI project, on this project. And I was very happy, first because we received a prize, and the prizes are very good, but because there are a lot of interest in the researchers that attend the conference. And I was more skeptic that before me there are huge numerical models on hemolysis, on VAD, on heart valve, so very important from the scientific point of view things. And after that I presented this research, I have a lot of questions, a lot of interest from the research. So I want to thank you, the organizing of this school, because I think that it is very important that starting from the PhD, the researcher, because you are a researcher, start to understand the importance of the research, both from the research point of view, so how fascinating is the research, but also from the social impact. So I will let with this slogan, let's make the BAMBI change the tail, save the mom. Thank you.